So today's topic is bowl from a board, which is a type of segmented wood turning where you get an entire bowl made from what started out as a board. And so this is one I made a few years ago. I call it the spider web bowl. Using the same basic board, I made a second version of that bowl, which I couldn't bring because we sold it about 2 weeks ago, where rather than having the spacer lines aligned going up through the once you reassembled the cut rings, they were staggered, and it gave this pattern instead, which I thought was a more interesting pattern, and the person that bought the bowl thought it was a more interesting pattern too. So how do we make the boards? Well, that's just a matter of laminating wood together. For these projects, you want to be using kiln dried wood because you don't want the wood changing size and shrinking more in one direction after the whole process is made. And so this is a board that Beth and I made yesterday. This is her project. In this case, eventually the bowl is going to look a bit more like this, where the outsides of it are going to be this whitewood, which is spalted elm, and then the colored strip is going to rotate through. And so when you make one of these things, in addition to making sure that, so this part of the wood is actually not kiln dried, but this is probably was a tree that was cut about 25 years ago at least, and it's just air dry, and it was given to us, and we've had it in our basement shop for 5 years, so it has no moisture content. The rest of it are just strips of different hardwoods. So we've got some black veneer, some padauk, maple, Choc de Viga, black walnut, and then that's just put together with Titebond to glue. And when we assemble it, we assemble it on a flat surface with a coat of plastic underneath it to keep the wood from drying to what we're gluing it together. And we have both sideways clamping action as well as downward clamping action on this so we don't get buckles. After the thing is glued up, it then goes through a drum sander, and we want to make sure that the surface is smooth enough that it'll glue together when we cut rings and stack them, and also we want to make sure that it's uniform thickness from left to right. If it isn't, it's not going to work well on the Ringmaster. The finals, after you've gotten it flattened, we cut a circle, which in this case was the biggest circle within the square block we had to begin with, and we also drill a 1/2-inch diameter hole. The reason that hole is there is to fit on the Ringmaster. So before I get around to showing the Ringmaster, these are segments I cut for what's called a vortex bowl. It's a more complicated glue up. I'm not going to get into that today because we're not really making this, but this is just what the rings look like. And as they're cut out, you can see that you're getting these rings from the board, but when you reverse the orientation, they stack and then can be glued together. And again, we'll have a swirled pattern on it. And there were more rings than this, but I left the other ones at home. So we're not going to use this board today because we want to be able to cut these rings without cutting a few rings here, taking the Ringmaster home and putting it back together and possibly not having the right angle or something like that. So today's cutting is going to be done using just a piece of pine as an example. So this is the Ringmaster. It's made by the Ringmaster company. It can be either purchased as something that has its own motor and you're not using it on the lathe, or you can get one that's designed to fit your lathe. And so this one, uh, our lathe at home is exactly identical to this. And so we know that the height is right. And that's what varies between different models, is it's how big your swing is. And so this part is part of the Ringmaster. It's just a big piece of steel that screws onto whatever thread you have, and you had to tell them, well, when you purchased it, you told them which lathe you're going to use it on. So this is the 1 1/4 8 TPI thread, and there's the hole that this is going to go through. Now, this is the Ringmaster cutter, and the first thing you have to do is attach the carriage to the bed, the bed of your lathe, and make sure that this is perpendicular to the bed lathes. And so normally I would have had a good square and ran that up, but I forgot to bring the square, but I did bring a digital protractor, and so we can just check that here. These are great tools in case you've never. Yeah, it does. And so it's zeroed out. That's the backup battery in case this one decided to wear out. And I'm getting, actually it's off a little bit, so I'm going to readjust it. It's off by about 2/10 of a degree, so we'll see if we can get that a little bit closer. 90. Yeah, with this square, that's a lot easier, but we're going to be doing more angle work later. Okay, so great question. So what you really want to do, and I'm going to have to adjust this in a second. I want this thing to be centered right through here. But once it's square, Beth, could you come hold one half of this while I hold the other? Okay, just hold that. Okay, that's square enough and it should now work. Okay, the next thing we want to do is mount this. I already pre-drilled that hole. It gets a big washer. And then a nut. And I'm also going to tighten that up. Now, if you've done everything right, this should be running true and not wobbling. If your hole is crooked, it will wobble, and that's not desirable. Okay, I'm gonna okay, I have to take that off because okay, Beth, remember this number, 26.3. Okay, so where does the 26.3 come from? Okay. So the Ringmaster comes with this book, and the most important part besides the instructions on how to put it together and use it are this table, which is tells you what angle you should be using based on the thickness of your wood. And so I measured this earlier. We happen to be I think it was 47/64. I measure it actually with a digital caliper because this chart is also digital. And there's a bar here that you may not see, but it has increments holes that are close together and holes that are a little bit further apart. So we're going to be using the holes that are further spread apart. And so we go down to the dimension I said, read off from this chart, and it tells us what angle we want it to be. So how do we set that angle? So now we have to, this is how the angle sets, and the way to set it, there is a scale here, which I don't know why they put on, because it's not accurate enough to be useful. So really, again, it's the digital caliper, and we run one section up against the front of that, which is a flat surface, and the other along the edge. And so that was 26.3. So I'm going to now set that at 116.3 because it's plus 90. And I've got it. Pretty good. Okay, so now what I have to, and Beth, you could come hold things again. So there's, this device is held down by a screw at a bolt at the front, a double bolt at the front. The lower half of the bolt is the one that's fixing the angle. The upper half of the bolt, as well as the bolt behind it, attached to two metal bars that slide along these posts here. And so now we're going to advance that up and okay, and there are two cutters on the Ringmaster, a left cutter and a right cutter. And so we want to advance it so that the right hand, so that the block can fit between the cutters, and that the left-sided cutter is just going to hit the edge of our block of wood. And it's set fine now. So I'm tightening down the rear one now, and I'm going to have a bolt on the an open end on what I just clamped down, and then use this to tighten the front bolt without messing up my angle. Hopefully. And is the lathe plugged in? That's the next question. Good. Something. Yeah. Okay. So now we're ready to cut the first ring. And there is an order of cutting. We advance this cutter in first, go about halfway, and then come from the other direction. Now the cutters are these two little bars here, and I haven't said anything about them. They're steel. You can get ones that have a carbide blade at more expensive. You can cut a lot of bowls before these wear out. They're shaped so that they're slightly angled, and can you see these set screws? The set screws have hold those cutters in a slot, and you may need to make sure that the set screw, that the thing is all the way back. It's not at an angle or something, because if the two blades aren't aimed at each other, you're going to have some sort of jump in the middle of your cut. So those were already, just tightened yesterday. The next thing I need is, I had mentioned that there's a series of holes, and so there's this little pin now goes need to make one adjustment here. I need to adjust the spacer thing so that the first thing drops in the hole. Okay. Now the speed I cut these at are around 500 RPM. You've got a safety shield here so you don't have to wear your face mask while you're doing this. You know, slow, steady, you don't want to force it. Lovely smell of cutting pine. So while you're doing the second cut, maybe I'll just stop for a second. While you're doing the second cut, you want to keep noticing whether you're knocking chips out or whether suddenly it seems like there's no resistance anymore, because you would prefer to stop the ring being cut before it's separated, just as there's a tiny wafer of wood left. Okay, so I didn't quite catch it, but the ring didn't explode anyway. So, and this is just a waste ring. It really depends on the swing of your lathe. Oh, you can go over an inch if you want to. That's the biggest I've ever done. If you're using the spacing well, okay, depending upon which spacer, if we made a thicker board, we would have a sharper angle, and so the pieces get taller as you go. So if you decide that you really want a thick board, you can, well, I said there's the short gap and the long gap. I've also used double short gap, which puts a bigger ring thickness than the wide one. And the advantage of that is it gives you enough additional wood that you can start doing some shapes that have more curves to them rather than straight sides. Okay, since that one was just junk, I just got rid of it. And so we're going to now move this forward. I would have moved it backwards to get the ring out and then forward, but we're going to move it just forward in this case. Now we have to show that they stack. Well, I can cut these rings a bit faster because it's pine, so. Yeah, I probably will resharpen ours because they're probably no longer as sharp as they used to be. Okay, so. Yeah. Yeah, there's two blades. Okay, so that one is ready to. Yes. Well, you could do it a different way, which is you could take a cutter out, but that takes longer to do because it needs to be advanced anyway, right? So we just go back, go forward. Yeah. And they have, okay, it would be good to take the close-ups after I cut this next ring because then I'm going to take this off after that. Okay, we'll blow some dust off it. So, okay, so what's that? No, not it makes some vibration no matter what. But I'm cutting faster than I would on hardwood because this pine just, obviously cuts quite easy. So that's the last ring I'm going to cut. Okay, so they stack. And it's because the angle was set accurately to match what the chart said it should be. So so how do we go from rings to a bowl? And so on mine, what I tend to do is start with a segmented ring of a contrasting wood. Uh, this happens to be purple heart. It's just 18 segments per ring. And then I put a plug in the center of a light colored wood. Uh, there's a number of ways you could try to stack these rings, but the one I'm going to show you is the one that's working best for us. We've tried doing it with a bull stomper, if you know what those are. And the trouble is that these rings that have angled sides don't line up very well on them, and you get rings that are not fitting together. So the method that we do is to assemble them on the lathe. So there's my block, and what I want to have is I want this to be sitting in this direction, right? So that that fits into the coal jaws here. That should be on center with respect to that. And so I would just then put glue on this, bring it forward. That should be centered, and I would make sure that I've got this the way I want it to be, centered with respect to the grain on that plug. so that matches the bottom of my bowl. So that's how we do it, and then we just keep building up until we finally run out of capacity on this, um, where we're up to, this will do maybe 11 inches. So the last couple rings have to be centered with a Longsworth chuck instead. I don't like to use the Longsworth chuck for the whole thing because these rings are definitely flexible, and the way you use a Longsworth chuck, you're bringing in 8 rubber bumpers from the outside. I think we can, if you bring them the first 2 in too tight, you distort the rings a bit, particularly if they're cut at the thinner spacing, and we run into alignment problems. But this method works pretty good. One thing I should have mentioned that we normally do is we put a pencil line down the original block so that we know that which which side of the whole block the pieces are coming from, and then we can keep that constant even as we do the rotation. Now, these blocks were assembled to be symmetric, so you would think it really wouldn't matter, but it still seems to be right. Right. Yep. And so if you look at these, there's a little pencil line uh, running through the center segment right there. You can't see it from where you are, but it's just a little pencil line. The other thing I should have mentioned when we get ready to assemble these is you need to run some sandpaper right along your ridge, because if you looked at these up closely, you'll see there's torn grain where the cutter goes in on both sides. And so you want to get that in so that torn grain doesn't end up in the way in the middle of your joint. Anything else that I've forgotten to tell them? Oh, so I guess you can see that this, by the time this hits the lathe with a tool, it's already about 1/4 inch thick is all that's left. And so we don't do a huge amount of turning on it. It's really light strokes to try to get it in round and flattened before we go to sandpapering. The one time we tried using the much thinner spacer was on this bowl, which was about the second thing we ever made. It had such thin segments that I basically chickened out at a certain point. I mean, it was barely over an eighth of an inch, and that one had to be hand sanded basically. Even sanding when it was moving wasn't really doing the trick. So I never used the single spacing. I don't know. It's maybe okay for really small pieces, but after that, the alignment issues get so bad that it's not a good approach, I believe.